Hey everyone, my name is Matt Moore, and this is the Git workshop for RowdyHacks, where we'll go over environment setup for your team projects. So before we begin, we need to answer the question, what is Git? So Git is version control for your project files. It enables you shared storage for your code base. It's a system for tracking changes in a project, and it's incredibly team-based and collaborative. This is really, really good, especially if you're trying to see who on your team is introducing changes to your project. So let's get some vocabulary out of the way. First, we have repository or repo, which is an entire code base which can be stored locally or remotely. And what I mean by that, first off, we have local repo, which is an entire code base that's stored on your personal machine, on your computer. A remote repo, on the other hand, is something that other people can access. So like an online storage platform like GitHub, which we'll be talking about. And then version control. This is a system that keeps track of history. So there are a few prerequisites that we have before getting started. First off, with Git, we're going to be using the command line interface. There are a few GUIs out there that you can use as well, but we'll be focusing on that instead. For Git command line interface, that should be already installed on Mac OS and Linux. If you're using Windows, I believe that you can install Git Bash, and that should help you out. And then also we'll be using GitHub. So one thing you'll need to do is create a GitHub account. And if you're interested, you can download the GitHub Student Developer Pack by using your school email when you sign up. And that gives you access to a lot of really cool stuff. All right, so let's take a look at our initial remote setup. So setting up your repo on GitHub, you just need to log into GitHub, create that account, and then whenever you have your account ready to go, you're going to click New under Repositories. On the next page, you'll name your repo. You'll give it a brief description about what your project is about. You're going to skip the last check that's regarding the README and then click on Create Repository. Okay, so let's take a look at our initial local setup. Before we begin, we just want to make sure that we've properly installed Git on our computer or that it's already installed. So to do that, you'll open up the command line, which is either terminal or git bash, and you'll use the command git -- version. If you get a version number, great, that means it's properly installed. If not, then you may need to download Git or look up some other means to make sure that it can get installed on your computer. So next we need to initialize a Git project. The first thing that we need to do is make a project directory. This can be housed on your computer anywhere that you like. Just make sure it's something that's easily accessible to you. Then you're going to move into that project directory using the command line. So if you don't have a lot of familiarity with this, I would definitely recommend looking up some of these commands. You can see some examples of what I did here. And then once you're in that directory, you're going to initialize the project with git init. And that will create an empty Git repository within that directory. So the first thing that I would recommend here is setting up your username right away. If you'd like to just set this up for your current repo, use the top command. If you'd like to set it up globally for all of your repos, then instead use the second command. Same thing with your email address. Let's just go ahead and set those up right now. You can either do it with your current or all of your repos all at the same time. All right, so let's talk about that first commit. First off, we're going to create a file in our project directory. We're just going to create a simple README right now. And second, we're going to stage that file for commit using git add readme. Then we're going to commit the file with a message git commit and with the M flag, and then our first commit. That's going to be the message that's pertaining to that commit. Then you can use git log to review your commit history. This is going to be really helpful, especially when you get a little bit further down the line into your project and you need to start keeping track of when you committed certain things from your project. All right, then the next step in our process is pushing to GitHub. And right now, we're not really focusing so much on actually following along and doing it, but I want you to take a look at some of the commands that I've put in here so you can see the process. So first thing that we do is add the remote repo using git remote add origin and then our repo URL. Second, we're going to push the commit using git push uflag and origin master. And this is all going to make a lot more sense a little bit later on. But the one thing I want to point out right here is if this is your first time, you may need to log in with your GitHub credentials. So if you're feeling a little bit lost right now, that's totally fine. These same instructions are provided every single time you create a new repo on GitHub. This can be really helpful, especially when you're just getting started, because these are a lot of commands to remember. Okay, so next we're going to start digging a little bit deeper as we talk about the staging area. One of the words that I've already thrown around a couple of times is commit. So if you don't know what this is, a commit is a snapshot of your code. This is really helpful so that you can keep track of the changes within your code base. A commit will include some information like the creator or the author, the time that it was created, and a unique hash. This will also include messages from the commit author, which can be used to identify the commits as you start looking through them later on. So if you imagine it like this, let's say that you've created a file and you're pretty happy with it right now. Then you go back and you want to add something in and remove something from that same file and replace what you removed with something new. After a while, you start doing like my file, and then my file copy, and my file final, and then final, and it basically just gets to be a long string of the same file just rearranged in different ways. You can kind of think of your code base the same way with commits. So let's imagine that we started here on the left side with this first node. That's going to be our first commit. After a while, we've made a few commits, and then we've made it to this next place. The great thing about having commits rather than just duplicating files is that it's always the same file, but you're still able to access from the history. Okay, so the staging area. This allows you to select which files you want to include in a commit. So Git is only going to be looking for new, updated, or deleted files to be staged. The reason for this is if you have a large project where you have a lot of files, it's really only going to be looking for the ones that something has been done to, ignoring everything else, which is very, very important. So any files that have not been staged are currently unstaged. This is what the staging area looks like before any new, modified, or deleted files have been staged. So if you use the command git status, you'll be able to see in red that we have this deleted file, a modified file, and then file 3 is a new file. So once a file has been staged, you'll be able to see it by using the same command git status, but now that file will be green. And to stage a file, you use the command git add and then the name of the file. So after a file's been committed, you're still going to be able to see all the remaining files that were unstaged at the time of that commit with git status. What we really want to focus on here, though, is the actual commit command. So git commit, the M flag, and then the message. So this message is what's going to be pertaining to the file that was committed or the array of files that we've committed. So if we take a look at our commit history, here's just an example. Before the commit, we had 3 files. We had the README, we had file 1, and file 2. And then after we made that commit to file 3, you can now see that the project includes that file, but file 1 and file 2, while they've been changed in some way, they still exist in the project. All right, so let's talk about pushing to a remote repo now. Since we've already set up our remote origin previously, all we need to do now is use git push, and that will transfer all the data from our local machine to our remote repository. On GitHub, all our commits made locally have been pushed up to the codebase, and so now you can see them here. And the great thing about this is, especially since we're working on team projects, is everybody on your team should be able to access this as long as your repository is public. All right, so next, branches. A branch is a divergence from a particular commit. This is really useful when you're starting to split up work in a project, so i.e. team projects. So let's take a look at branch 1. Looks like we already have 4 commits right there, and at this point we're deciding, you know what, it would probably be best if we started to work on this next feature separately. And as we get further into a project, it might make more sense to create multiple branches, all branching off from different commit points. Our master branch is arguably the most important branch in our project. All Git projects begin on a master branch, and a good way to think about this is it will store your stable, deployable production code. New features are almost always developed on a different branch than master, and it's generally not a good idea to push code directly to your master branch. So to create a new branch, we're going to use the command git checkout and then the B flag, and then the branch name, whatever we want to name that branch. This will create a new branch off the branch that we started on, so in our case, we started on master. To be able to see all the branches that are currently on your local machine, just use the command git branch to get a list. To be able to jump to an existing branch in your project, use the command git checkout and then the branch name. And basically what this will do is take you from the branch that you're currently on to the branch that you would like to go to. So now that we have a little bit of a foundation for what we're doing, let's talk about Git in our development environment. So to illustrate some of the points that I have lined up, I've already set up a new project. Local and remote repositories have been initialized, and some of the files have already been committed and pushed. So if we look at this new project directory that I'm working from, Git Demo 2, we have 2 files, index and readme. So for the rest of this workshop, I'll be using an IDE. I'll be using Visual Studio Code. However, if you decide that you'd like to use another IDE, that's fine, as long as you have a terminal open and that terminal directory is the same as your project directory. So the first topic that we're going to be talking about with this project is merging. Merging brings changes from one branch to another. This is really helpful when you're working on a group project because you may have created a branch specifically for one feature, and once that feature is completed, you want to be able to merge it back into your production code. One thing I want to note here is that sometimes those merges can result in conflicts. A merge conflict is when a change to a file in your branch conflicts with the same file in a branch you're merging into. So in this case, we can think of this as the source branch and the destination branch. On our destination branch, we made a few commits and then we branched off to a new branch, which is now source. While we've been creating some commits on our source branch, it looks like somebody made a commit on our destination branch. And let's assume that 2 of those commits conflict with each other. This would result in a merge conflict. So for example, let's say that we're on master and we've committed a file. Next, we switch to a new branch called merge conflict example. Creative name, right? We've changed some code and then committed that file. Now back on master, let's say that you, me, or somebody else changed code after that branch was created, and then they recommitted the file. Now back on the merge conflict example branch, if we attempt to merge into master, it will fail because there's a conflict. So this is a pretty simple example of what a merge conflict might look like. We're only dealing with one file here, but we can see that there's 2 different opposing segments of code. So the first one up at the top head is the code from our current branch, and below is from our master branch. It's our job at this point to determine if we're going to accept the current change, which is from our current branch, if we're going to accept the change from the incoming branch, which is from master, if we're going to accept both changes, or if we need to do something a little bit different to ensure that our code is not disrupted. So the last thing that I want to say here is don't worry too much about the syntax right now. We'll come back to merging code. I just wanted to show you what a merge conflict looks like high level. A pull is when we download all the changes from the commit where the local and remote diverged. So essentially, any changes that have been made and pushed remotely are now pulled into the code base that we have in our local repository. Changes are automatically made to the files in the local repository, so you don't need to worry about that unless, of course, there's a merge conflict. To do a pull, we'll just use the command git pull, and that'll bring all the changes in from our remote repo. In this case, where you can see in this example, everything's already up to date. Sweet. Okay. Next, pushing. This moves all the local changes from our repository to our remote repository, so kind of the opposite. Here we can see in the before box that our remote repository does not quite match up to our local repository. There's been a change. So if we push, we can make that change from our local repository get pushed up into our remote repository, so they'll match. There are a couple steps for pushing. Number 1, use git pull to bring in any new changes first. This is super important because if any changes have been made remotely, we want to make sure that we bring those in first to our local repository in the event that there might be a merge conflict. If there are any conflicts, we can resolve them, and at that point, and that point only, should we use git push to push up to the remote repository. So I know it's a lot of information, but now we're really getting into the meat of our workshop. Let's talk about working collaboratively on GitHub. The first thing I want to talk about is a pull request. A pull request does a few things. It'll notify team members that a feature has been completed. It's a dedicated forum to discuss any changes that need to be made to that feature. And it's also a really great tool to merge in changes from another branch once they've all been approved by the team. So to file a pull request, you'll need 4 things: the source repository, the source branch, the destination repository, and the destination branch. For us, we can assume that our projects will have the same source and destination repositories, so really let's just focus on the branches. So by looking at this example on GitHub, we can see that our current branch is the admin login. That's our feature branch. Next, let's go ahead and click New Pull Request. This will take us to our next dialog, which will give us some information about what we're trying to do. Our destination branch in this case is master. Our source branch is the admin login branch. That's the branch that we're trying to merge in. And then also our merge status. It says able to merge. That's great. That means there's no conflicts and we can get right to the pull request. Directly below that information, we can name our pull request. We can write some comments about what the feature is and how it's going to be merged in. And then also, if we have any team members that need to review it, we can also select them on the right side. After that, we'll just create the pull request. So now that this pull request has been made, I want to talk about a few things that this allows us to do. Number one, we can review the commit history and the changes to the files. This is really great because without downloading any of the code, we can look in GitHub and see what's been changed. Also, this provides line-specific code review. Not only can we make comments about a particular commit, we can also look at individual code segments within files and make comments about them. We can continue to push code when code changes are requested, so once a pull request has been made, if somebody requests a change, you can still make changes locally and then push them up. And then finally, once everything has been approved by the team, you can merge in your code. So I really want to highlight the once reviewed part of this because since we're working on a team, we want to make sure that everybody that's going to be affected by this change has a chance to review it and approve it. Once it's been approved, then you can merge the pull request with the default button, Merge Pull Request. What this will do is take all the commits from that pull request and merge them into the destination branch as individual commits and in the order that they were committed. If you want to use a different feature, which is squash and merge, essentially what this will do is it will group all those commits together and then merge them as one single commit into your destination branch. This can be really helpful, especially if you want to keep those commits together. After a pull request has been closed, we always want to use git pull, and we want to do this as a team. This ensures that everybody's working from the same code base, and not to worry, all of your other working branches are unaffected by this. So we're getting pretty close to the end, but one thing I definitely want to talk about is cloning a project. Not all projects need to start from scratch like we've been doing. Only one person really needs to initialize a remote repository on GitHub when you're working on a team. So once that project's been initialized, just copy the repository URL from GitHub and use git clone with the repository URL to copy the existing project on GitHub to your machine. I also want to talk about git ignores. A git ignore is a simple file that's always titled .gitignore and it's stored in the root of your project directory. What this does is it prevents specific files and directories from ever being included in your staging area. This can be really useful when your project includes things like dependencies that need to be installed or any personal files that should remain only on your machine. And here are just a few more things for your own information. There are a lot of advanced topics that we didn't get to cover here. I really just wanted to focus on some of the basics so you can start digging into your projects. However, if you so choose, I would definitely recommend taking a look at some of the documentation on these topics that are all over the internet. And I think we also need to talk about graphical user interfaces. I personally am not a fan of using a GUI with Git. However, if you so choose, you can use git GUI command, and that will pull up this window so you can start to see a little bit more of a visualization of what we're doing with these commands. Also, it's been recommended to me to use git fiend. From what I've seen, this is a really, really clean tool that helps you with your Git commands and with your visualization. So if you're interested, I would definitely recommend downloading it. And that's all I have. I really just wanted to cover some of the basics of Git and using Git on a team. If you have any questions for me, please feel free to reach out to me on Discord. I've dropped my handle right there. And the last thing I want to say, hope that you learned something and hope that you enjoy the rest of RowdyHacks. Thanks, everyone.